The aim of this experiment is to observe the action of zinc, iron, copper and aluminium metals on the following salt solutions: zinc sulfate, iron sulfate, copper sulfate and aluminium sulfate. The material required for performing this experiment is, you will need some test tubes, a test tube stand, distilled water, 4 metals, that is iron, copper, aluminium and zinc, solutions of iron sulfate, copper sulfate, zinc sulfate, aluminium sulfate and some paper strips. So let us first understand what actually happens when we are going to perform this experiment. All the reactions involved are going to be based on displacement. So what is displacement? It is when a more reactive metal displaces a less reactive metal from its salt solution. So the metal which will be the most reactive will displace the maximum number of metals from the salt solutions, and the metal which will be the least reactive will displace the least number of metals from their salt solutions. Let us see how this experiment is going to be performed now.
The apparatus required for this experiment is, we have a solution of zinc sulfate, we have a solution of aluminium sulfate, we have a solution of ferrous sulfate and we have a solution of copper sulfate. We will be testing each of these 4 solutions with different metals. We will be using iron, we will be using copper, we will be using aluminium and then we will be using zinc. So first of all, I have this aluminium powder with me. I have 4 test tubes in which I will add some of this. We have taken a small amount of aluminium powder in each of these 4 test tubes, and now we will be adding zinc sulfate to the first test tube and see how the reaction works. To the second test tube, I am adding aluminium sulfate. To the third test tube, I am adding ferrous sulfate. And to the fourth test tube, I will be adding copper sulfate. So we need to see how the reaction occurs. In the first test tube, where we added zinc sulfate, we will find that aluminium reacts with zinc sulfate, forming aluminium sulfate, and zinc will get displaced. You can see the change in the color happening here, which shows that a reaction is occurring and aluminium is displacing zinc from zinc sulfate, showing that aluminium is more reactive than zinc. In the second test tube, you can see that the aluminium that we added has settled down at the bottom and there is no reaction taking place. Obviously, aluminium cannot displace aluminium itself from its salt solution. In the third test tube, we took ferrous sulfate. So we find that again a reaction is occurring here also. So I am giving it a shake. You can see that the green color of ferrous sulfate has disappeared and aluminium has got converted to aluminium sulfate here, and iron will be seen settling at the bottom. So it will take some time to see the iron deposits at the bottom of the test tube. And then in the fourth test tube, where we added copper sulfate, if we give this a shake, we will find a reaction taking place here also, like aluminium getting converted to aluminium sulfate and the copper metal getting deposited at the bottom, showing that aluminium is more reactive than copper. So what we can conclude from this experiment is that aluminium can displace zinc, iron as well as copper from its salt solution, showing that it is more reactive than any of these 3 metals.
So with aluminium metal, when we added aluminium metal to aluminium sulfate, we observed no change. The reason is that aluminium obviously cannot displace itself. When aluminium was added to a solution of ferrous sulfate, we found that the pale green color disappeared and the solution turned colorless. If left over a period of time, we could see the black deposits on aluminium metal, which were of iron. Because aluminium is more reactive than iron, it displaced iron from its salt, resulting in the formation of aluminium sulfate, which was colorless, and iron got deposited on the aluminium metal that was lying at the bottom of the test tube. When aluminium was added to zinc sulfate solution, since aluminium is more reactive than zinc, we could not observe any such change in the color of the solution because the solution was already colorless, but we could observe some deposits on the aluminium metal again, suggesting that aluminium displaced zinc from its solution, forming aluminium sulfate and zinc. This again proves aluminium is more reactive than zinc. Then when aluminium was added to copper sulfate solution, the blue color of the solution faded out and we could see the reddish deposits formed all over aluminium, which were deposits of copper, suggesting that aluminium displaced copper from its salt solution, resulting in the formation of aluminium sulfate and copper. So this proves that aluminium is the most reactive of all the four metals that we have taken, because apart from itself, it has displaced iron, zinc as well as copper from its salt solution.
Now we have taken a small piece of zinc metal in each of these four test tubes and we will be testing it with aluminium sulfate, iron sulfate and copper sulfate solutions to see which metal it can displace and which it cannot displace, which will prove that zinc is more reactive than iron and copper and less reactive than aluminium. So in the first test tube, I am adding some aluminium sulfate. You can see nothing is happening here, showing that zinc is less reactive than aluminium, so it cannot displace aluminium from its solution. So no reaction occurring in the first test tube. In the second test tube, along with zinc, I am adding iron sulfate, FeSO4. So if we keep this for a while, you can see the change in the color taking place. If you compare the two solutions, you can see the color fading out. So slowly the solution will turn colorless because it will result in the formation of zinc sulfate and you will be able to see iron particles settling down. You can see the difference in the color. It's slowly fading out because the reaction is slow. It's a block of zinc. If you take fine pieces of zinc, then the rate of reaction would be faster. You can see the difference in the color coming in, showing that zinc is more reactive than iron. In the third test tube, we are adding copper sulfate solution. Look at the color of zinc, it has lost its shine. Why? Because copper has started depositing on it. So you might not be able to see the change in color of the solution, but you can definitely see the change in color of zinc, and it's looking black because of the copper that has started depositing on it, and as you keep it for some time, the blue color will start fading out because copper sulfate is going to get converted to zinc sulfate, showing that zinc is more reactive than copper. You can see the difference in the color. Like this was what I took initially, zinc, and look at it now. It's turning darker, showing that copper is getting deposited on it. So zinc is more reactive than copper.
Let us now check with zinc. So when zinc metal is added to the same four solutions, our observations were that zinc when added to aluminium sulfate did not produce any change, showing that zinc is less reactive than aluminium. When zinc was added to zinc sulfate solution, again no change was observed because a metal cannot displace itself from its solutions. But when zinc was added to ferrous sulfate or iron sulfate, the green solution faded out and some black deposits of iron were seen on zinc metal. So which suggested that zinc is more reactive than iron, and that is why it could displace iron from its salt solution, resulting in the formation of zinc sulfate and iron. When zinc was added to copper sulfate solution, again we could see that the blue color of the solution faded out and we could see those reddish brown deposits on copper. We could see those reddish brown deposits of copper which got deposited over zinc. This suggests that zinc is more reactive than copper, and that is why it could displace copper from copper sulfate, resulting in the formation of zinc sulfate and copper.
Now I have taken some iron filings in each of these 4 test tubes. Let's check this with zinc sulfate first. No reaction occurring. You can see the iron filings are settled at the bottom of the test tube and the zinc solution is there at top, showing that there is no reaction between iron and zinc. Hence iron is more reactive than you can see that the iron filings are settled at the bottom and the zinc sulfate solution is there at the top, showing that no reaction is occurring here. This proves that iron is less reactive than zinc. In the second test tube, we are adding aluminium sulfate. So if I leave this test tube for a while, you will find that the iron filings, they will again settle and aluminium sulfate is present at the top. Nothing happens here also, showing that iron is less reactive than aluminium, hence it does not displace aluminium from its salt solution. In the third test tube, I am adding iron sulfate to iron filings. So obviously iron cannot displace iron, so no change to be observed here as well. And in the fourth test tube, I am adding copper sulfate solution to the iron filings. You will see a change in color here. Copper sulfate solution, which was blue, now the solution is gradually turning green, and green color is a characteristic of iron sulfate, showing that iron is reacting with copper sulfate, resulting in the formation of iron sulfate. And you can see that the color of iron filings is changing to brownish red, which is because copper is getting deposited and the solution is turning to iron sulfate now. Initially it was blue in color and now it has turned green. So that means iron is more reactive than copper.
When we tested the solutions with iron metal, we found that when iron was added to aluminium sulfate, there was no change. We already know that aluminium is more reactive than iron. When iron was added to zinc sulfate, then also no change occurred, suggesting that iron is less reactive than zinc. Then iron was added to iron sulfate itself, obviously no change because the metal cannot displace itself. But when iron was added to copper sulfate, the blue color faded and it turned green because iron displaced copper from copper sulfate and formed iron sulfate, which is responsible for the blue color. And copper got deposited at the bottom or on the iron filings that were there in the test tube.
Now I have taken copper turnings in each of these 4 test tubes. To the first test tube, I am adding zinc sulfate solution. No change occurring here. In the second test tube, I am adding aluminium sulfate solution. Again, no change. In the third test tube, I am adding ferrous sulfate. No change again. You can see that the color stays the way it is. And in the fourth test tube, I will be adding copper sulfate. And you can see again no change. This shows that copper is the least reactive among the 4 metals that we are using today.
When we tested with copper metal, we found that copper did not react with aluminum sulfate, zinc sulfate, iron sulfate or with itself, because copper is the least reactive amongst all these 4 metals that we have taken here, and hence it could not displace any of these metals from their salt solutions. So the final result that we could draw from this experiment is that out of the 4 metals that we took here, aluminium is the most reactive, followed by zinc, then iron, and then copper is the least reactive of them all.